Hello, okay, so today we'll be doing our math assignment presentation. So for my source, I got it from this site, and it states that the average click-through rate for a search ad is 1.91%. Thus, our null hypothesis will be the same, where the average search ad click-through rate is 1.91%, where mu equals to 1.91, and our alternative hypothesis will be the average search ad click-through rate is not 1.91%. So our mu is unequal to 1.91. So over here, we have our 30 data values. These sample data values are from search ad click-through rate percentages data, which are found on different websites that I collected. Okay, so from here we'll be going on to the mean, which has the formula given here, average of B2 to B31, which basically sums up all of these values divided by the sample size, which is 30, which in this case is 2.042. Next, we'll be going on to the standard deviation. So what the standard deviation tells you is how close the values are to each other. So we'll be using this formula, standard deviation dot s of B2 to B31. So what this dot s is, it is basically differentiating it from sample standard deviation and population standard deviation. And since it's s, it's a sample standard deviation. So our sample standard deviation value here is 0.422737. Okay, next we'll be going on to our t value. So how is our t value obtained? So basically, our t value is obtained by using our mean, which is our B32, minus our 1.91, which is our mu. So it's mean minus mu over our standard deviation, which is divided by the square root of our sample size, which is 30. And this gives us the t value. So why did we do t-test? That's the question. Since we do not have our population standard deviation, it is unknown, and thus we can't do the z-test, which is why we have to use t-test. Okay, so from here we'll be going on to our p-value. So our p-value formula is given by 2 times the t dot dist dot rt of L12, which is our t-value, comma 29, which is our sample size minus 1. Then we'll be going on to our margin of error. So the formula for our margin of error is given here too, which is equals to the confidence norm of our alpha value, and our standard deviation value, then our sample size value, which in this case gives us a 0.151 margin of error. And thus, we can find our 95% confidence interval using our margin of error obtained. So how we got this 1.891 here is by using our mean minus our margin of error to give us 1.891, which is the lower boundaries of our confidence interval, and our upper boundaries will be using 2.042 plus our margin of error, which gives 2.193. So since our p-value in this case, which is 0.097, is bigger than our alpha value, which is 0.05, there is insufficient evidence to reject null hypothesis, and so we won't do it, right? Okay, so what is this 95% confidence interval? So basically, the 95% confidence interval is a range of values where you can be confident that the values contain the true mean of the population. So 95% of the value contains the true mean of the population. So basically, for to explain it in simpler terms, is if you do a test 100 times, 95 out of 100 times, you'll get the correct answer. Yeah.